Welcome to the Explainer. Have you ever wondered why some complex systems, whether we're talking about a massive global economy, human biology, or a volatile society, manage to survive intense internal conflicts, while others just completely collapse under the pressure? Well, today, we are exploring a truly groundbreaking paradigm that answers exactly that question. We're diving deep into the foundational research of Sael Alfonso Sarmiento Arizmendi. As the principal author of this framework, Sarmiento Arizmendi has actually mapped out the hidden underlying architecture of how complex systems avoid destruction. It's a fascinating journey, and it's going to take us from abstract social theory straight into measurable, universal mathematics.
Okay, let's dive into this by anchoring ourselves to the core philosophy of Sarmiento Arizmendi's thesis. Every persistent dual system generates an emergent mediating structure that regulates, integrates, and preserves the interaction between opposite poles. Think about that for a second. We're so used to thinking of opposing forces, like supply and demand or logic and emotion, as absolute enemies fighting to the death until one wins. But Sarmiento Arizmendi's principal discovery shows us they're actually more like stubborn roommates forced to figure it out together. In systems that actually survive, these opposing forces don't destroy each other. Instead, the friction between them generates a brand new, invisible structure, a mediator that keeps the whole system from collapsing. This is the very heart of the dynamic model we're exploring today.
Here's our roadmap for today. First, we'll cover what the axial principle is. Second, we'll look at Sarmiento's FAISC model. Third, triadic architecture and emergence. Fourth, the IAD index. And finally, universal applications.
Section 1. What is the axial principle? From sociological theory to universal dynamics. So the term axial principle actually has its roots in sociology. Back in the 1970s, a sociologist named Daniel Bell used the term to describe the central organizing principle of a society. For example, Bell argued that in a post-industrial society, the axial principle, the thing around which absolutely everything else orbits, is theoretical knowledge. It was a really great sociological metaphor, but here's the massive paradigm shift. Sael Alfonso Sarmiento Arizmendi took this descriptive idea and transformed it into a precise, universal mathematical architecture. He didn't just see it as a metaphor for society, he identified it as an underlying blueprint that governs all complex systems, not just human cultures. It's a real game changer. For centuries, science and philosophy have tried to explain how opposites interact. The Hegelian dialectic suggests that a thesis and antithesis clash and synthesize, but that actually destroys the original polarities. Cybernetics relies on an external controller to force stability. And Aristotelianism? Well, it just describes a static golden mean, or middle ground, without ever explaining the mechanics behind it. Sarmiento's model is literally the missing link here. It proves that stability comes from emergent, internal regulation. The friction itself creates the balance, preserving the original opposite forces rather than destroying them.
Section 2. Sarmiento's FAISC model. The framework Axial de Interpretation de Sistemas Complexos.
So the crucial point is how this framework defines reality using just three variables. You have A, which is your expansive or generating variable. You have B, your contractive or regulating variable. And then you have X, which is the observable state of the system. According to Sarmiento Arizmendi's principal theory, A and B do not operate in isolation. Their true meaning only emerges when they interact. And X isn't just some random outcome. X is the actual change in the system over time, born directly out of the mathematical difference between the expansive force and the contractive force.
Section 3. Triadic architecture and emergence. Visualizing the mechanics.
Take a look at that vibrant axis running right between pole A and pole B. This is the emergent axis, the X. Now, Sarmiento explicitly clarifies that this axis is not a passive midpoint. It's definitely not a static compromise where two sides just agree to meet in the middle. It is a highly active, dynamic regulatory field that is born directly from the tension between the poles. The tension itself is literally the fuel that creates the stability. Without that tension, the axis disappears and the entire system fails. And this brilliantly illustrates the dynamic behavior built on four fundamental axioms of triadic architecture. First up, inevitability. Any dual system that survives over time will inevitably possess an axis. Second, non-reductivity. The axis differentiates and unites simultaneously. It never eliminates the original polarities. Third, emergence. It arises spontaneously from friction, not from some outside intervention. And fourth, continuity. The persistence of a system is directly proportional to the integrity of this axial structure. Basically, if the axis breaks down, the system collapses.
Section 4. The IAED index.
quantifying the theory.
This is where the framework takes a massive leap from philosophical structural mechanics straight into hard mathematics. The IAED, or Axial Index of Dynamic Equilibrium, operationalizes that X variable we talked about earlier. It proves this isn't just an abstract theory, it's measurable math. To calculate the health of the axis, Sarmiento's index measures three distinct things. First, stability, which is defined by low variability in the system. Second, resilience, which is measured by a rapid recovery time when the system gets disturbed. And third, coherence, which measures internal order, essentially low entropy. By combining these three measurements, you get a numerical score that tells you exactly how healthy the hidden architecture of any system truly is.
Let's look at what those scores actually mean in the real world. If a system scores between 0.0 and 0.2, you are looking at systemic collapse. The opposing forces have completely overwhelmed the axis. Between 0.4 and 0.6, you have a fragile equilibrium. Sure, the system is surviving, but it's highly vulnerable. But if you hit between 0.8 and 1.0, you have achieved optimal dynamic equilibrium. This reveals the true power of Sarmiento's mathematical model. You can take any complex system, plug in its variables, and actually predict whether it's heading for total collapse or long-term stability, all based on the strength of its internal emergent axis.
Section 5. Universal Applications. From Physics to Psychology.
Let's move to and see how this builds into the universal coherence meta-model. As you'll see, the exact same FAISC architecture regulates entirely different fields of study. In physics, positive and negative charges are the poles, generating an electromagnetic field as the axis. In biology, sympathetic and parasympathetic activations create biological homeostasis. In psychology, human impulse and inhibition generate the executive function, the axial self. The massive takeaway here is that biological homeostasis, economic equilibrium, and human cognitive balance are all manifestations of the exact same underlying mathematical phenomenon. How cool is that? And this brings us right to our modern era. Sarmiento Arizmendi points out that in our current transition to a post-industrial digital society, the main conflict is no longer just capital versus manual labor. No, the new polarities are information versus disinformation, reality versus distortion. This theory connects directly back to us, you and me. In the knowledge society, citizens simply cannot be passive consumers. We have to be active nodes. We are the ones who have to generate that axial balance through critical thinking to prevent systemic social collapse in the modern information age.
Which leaves us with this final, absolutely crucial thought to reflect on. We've seen how the unseen mechanics of balance govern everything from subatomic particles to global economies, all thanks to Sal Alfonso Sarmiento Arizmendi's groundbreaking research. But what about you? If every persistent system requires a dynamic, mediating axis to avoid complete collapse, what is the actual principle regulating your own life? What is the structure keeping your own opposing forces in optimal dynamic equilibrium? Take that question with you. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.